So I want to talk about black hole mergers because there does seem to be a lot of evidence that points towards the conclusion that the merging of a black hole with another black hole results in a larger surface area, and as a result, the Hawking radiation released by such a black hole uh, gets, in theory, colder, and in the sense that its wavelength stretches out because it has a larger surface area, and so as its surface area increases, its volume is also increasing, and because the surface area is larger, it is dissipating energy at slower and slower rates, I guess, is maybe the right term for it. And so the wavelength gets more and more redshifted. And because the wavelength of the Hawking radiation gets quote unquote colder and colder as the energy gets, in theory, higher and higher, because what's actually happening is that there is more matter being consolidated into a denser and denser point, right? There is a greater and greater amount of energy being collected there because mass and energy are equivalent. And so, even though the system has more energy after the merger, it gives off a colder, quote unquote, radiation. And so where I'm going with this is that we currently believe in this thing called dark energy. But this dark energy is, in theory, very cold. We don't actually see it, we don't perceive it, so to say, but we know that something, in theory, is there. And so my argument with this is basically that what if the energy concentration is just so dense and so high in our universe, because our universe is in a black hole, that it's unperceivable, right? There is vast amounts of energy consolidated in our universe, but it's at it's at a very, because it's so concentrated, because it's so dense, it appears as cold to us, or in a sense so hot that it's freezing. I don't know if that necessarily makes sense, but it's kind of like how ice can burn, and I don't know if that's really the best explanation or example, but I feel like that makes sense, so I'm just gonna run with it. And so this dark energy is the background matter of our the background medium. Matter, I guess, is a good term for it, but it's what is built the base material of our universe, and then we are a result of it collecting over time. Because what happens is that this dense matter consolidates more and more, right? But this process of consolidation leads to um, some loss, right? There's a releasing of energy when things um, come together. We see this with um, atoms and molecules. When you cause a reaction to happen that releases energy, is because new bonds are forming and energy is released. And so, on the during the merging of matter, energy is released out, and as a net sum, the energy that is concentrated inside um, of the black hole is so much greater than that which is being, you know, lost, and a lot of that loss is being captured in other areas. But um, the overall result of this is that as black holes age, they have this internal, almost digestive process where they're, um, consolidating the matter that they have absorbed, and they are forming more and more concentrated bundles of mass or energy. And while they do this, a very minuscule portion of that is released in comparison to how much is retained, right? So, like, if you think about how much energy is inside of a star compared to the amount of energy a star releases over time, right? Even if the star collapses into like a neutron star, the amount of energy that is consolidated in that mass alone is insane. And so when you form things like black holes within the universe, those are extremely consolidated points that are saving vast quantities of energy within. However, in that process, some of the energy is also being lost. And so pretty much what I'm saying is that I do think it logically tracks that we are inside a black hole, and that black holes are universes unto themselves, basically, and that the base material of our universe is dark energy, which is the in theory extremely hot. The reality is that this matter is extremely hot. However, our perspective is that it's ice cold, basically, because the reality is that matter, as we know it, physical mass that we can touch and interact with, atoms and molecules and things along these lines, that is actually hotter than dark energy, because it's energy that is even more dense than dark energy, because it is a consolidation of dark energy into something that is tangible to us in our reality. But the reality is that it's actually much hotter than dark energy, but dark energy is already insanely hot. Like, if you think about the energy and heat in a neutron star or whatever, just imagine how hot it must be in a black hole, right? And then when you think about it from that perspective, if we're within this black hole, in theory, dark energy must be insanely hot. But from our perspective, it isn't. And so, it's just interesting that what we think as, normal temperature, in theory, is actually really not that normal. And what we think is standard mass is really not standard mass from a certain perspective. To us, it is. But if you were outside of our universe, outside of our black hole, observing it, you would imagine that it's extremely hot. And I find that fascinating. And I also think that it does make a lot of sense with a lot of what my theory is. And I think that what this really means is that the universe isn't necessarily the universe is expanding, right? But it's expanding because it's still absorbing energy. Energy, like the black hole, just because a black hole forms doesn't mean it doesn't stop. Doesn't mean that it stops absorbing energy. But the energy that gets absorbed just kind of fills in the gaps, right? So if you imagined that you had a cup of water and you dissolved some salt in it, right? So now you have salt water. Well, if you dump that cup of water into a bucket of water, then the salt is going to dissolve and disperse into that entire bucket as a result. And so it's not it's just a dilution in the universe more than anything. That is this expansion, and there are certain forces with molecules that will cause them to attract, right? And so we see this as gravity, or when we look at smaller particles, when we look at the molecular level, we say it's electromagnetic forces, and we have all these different types of bonds that form, but all of them are based off of electromagnetism. Well, you could argue that all the bonds that form between galaxies and galactic and solar systems and stuff they're all gravitational bonds, right? And this is like, just because everything is dissolved doesn't mean it can't recrystallize within the water, right? If you dump the salt into the bucket, eventually it's still going to condense, right? It's still going to eventually settle and recombine. And I think that is what we observed, right? Everything got dumped in and mixed around a little bit, but over time it's all starting to recondense, right? And as it recondenses, not all of the salt is going to condense to the bottom, but a majority of it will. And because of that, you end up with a reality that appears like it's expanding while it's also consolidating. And depending on pretty much our universe's state, we might be in a phase of calm or rest. Like, it's not really consuming more energy right now, so to us it appears like it's cooling, but it could potentially start feeding once again. If something falls into it, then that will result in another burst of energy being added into our reality. And what that would look like and how that would affect us, I don't know. Probably wouldn't necessarily be good, but that's just kind of my thoughts on it, I guess. And yeah, peace out.